Okay, good day everyone. My name is Teguan. I'm the System and National Org Manager of Career. So welcome once again. Saw some familiar face somewhere in the crowd. In the crowd, not clouds. So today I'll be talking about implementing a government compliant architecture in the architecture, no matter what are the models, the happy models or not happy models. So the infrastructure actually remains the main key component in the entire architecture, because this is where you deliver your applications, this is where you host a server, this is where the digital service are being deployed to the public or to the end users. So with any infrastructures, so we know that there's bound to be challenges and problems that we face. So what are the three main common problems that we usually see when doing infrastructure implementations? Okay, so we'll talk about this problem, and later we'll see how IAC Infra as Code can help to address this problem. Before I start, let me give some history about myself. I've been in the IT industry for about 20 years. So those that knows me know that I've been dealing with system infrastructure for most part of my career. So infrastructure has actually evolved a lot over the past decades, and especially in these few years, you start to see innovations like converge, hyper-converge, all these new infrastructure start to spin up. So, but now today we are in the era of moving things to clouds. So, next question is, when your infrastructure moves to clouds, can you sleep better at night? So, show on the hand who agrees you can sleep better at night? Anyone? Or anyone disagree that you can't sleep better at night when your infrastructure moves to cloud? So, I believe those that are dealing with infra and the system team, they may think that you can sleep better at night. Why? Because there's no longer any alarm for amber light, disk failure, send storage down, firewall down, link down. All these things will be of the past. But how about for those people that's dealing with compliance, they're dealing with security? Okay, let's take a look at this happy model once again. So if I'm someone who's going to implement the infrastructure in cloud, the solution architect, I may be very happy. Why? Because the cloud is so flexible. There are so many resources that I can use. So example, if I want to build internet zone, the treated internet zone, I can actually have different type of load balancer here. Okay, I can actually have a virtual private network. So if I want to do something in the intranet zone, the tree tier, instead of private network, I can actually implement a private subnet. So for the databases, do I want to use a managed database? Do I want to spin out a VMware database, or do you want to bring your own license? So all these things are quite flexible and a lot of choices to use. And for the integration tier, what are the components that I want to bring in? So you see, this can be a big playground for the infra team, but for the security team and the compliance team, it's a headache, because with so many features, so many mix and match, how do you ensure that everything can be compliant? Like when you spin out a server, is it encrypted, or the kind of the situations? So this goes to the challenge number one that Ken says, compliance requirement. Because the flexibility in cloud and the compliance, they are not really very good friends. So how do we make them good friends again? So we talked a bit about cloud. So let's talk about how the ease of use in cloud. Example, I want to provision a server in the cloud. I will take AWS for example. So I go to the console, launch an instance. So from there, I choose a machine image. So the image is like the OS images. You want a Linux or you want a Windows. So even for like Windows itself, there are many flavors, many additions that you can use. So with that, I choose the instance type, which is like how many CPU, how many RAM that you want to use. So it could be like 2 CPU, 4 gig RAM, etc. So the subnet, which region do you want to put it in? Singapore or whatever. The hard disk size that you want to use, naming convention. Okay, I don't want to bore you with all these things, so I'll just fast forward. So you see, if you follow me through, you just need 7 steps, 11 clicks, and 5 minutes to configure one VM. So in the past, when we want to do a deployment, we request a server from a team. It may take hours, it may take days in order to get a server up to running and to get it set up. So right now, actually, in the cloud, within minutes, you can do it. But if I want to set up something as complex as a H model here, so I give you a clue. It's 13 subnets, 60 servers, 4 database, 6 load balancer, firewall. So conservatively, anyone want to guess how many clicks would that be? Someone? How about you? A rough idea? Okay. So it's actually 1,108 clicks. So this is just a conservative figure, just plain provisioning. So can you imagine you click through 1,108 clicks without making mistakes or errors? It's quite impossible, and this happens. So beside the clicking, actually you also need other resources like your network team to come in to assist on configuring the route tables, the ACL, that kind of thing. So this is challenge number 2, the human error during the process. So the third challenge I think affects project managers here is timeline. So in the typical infrastructure setup, when we order the servers and delivery, it takes about 6 to 8 weeks. I think you are quite familiar with that. So once the server comes, the network guy got to do the cable links, 1-2 weeks. Then once the cable is done, the switches comes in, the server comes in, the system team. After that, the storage team, database team. So all in all, 16 weeks, and that's a conservative timeline. So sometimes it may drag longer if some of this component delay because it has dependency on each other. And on top of that, the resources I mentioned earlier just now, your architect, your system engineer, your network firewall engineer, your EBA, all these are common resources. They are used by multiple projects. So you need to put them in advance in the time slot that they needed. But if they are engaged by other activity, your timeline will still run because they are not available to do this for you. So this is your challenge number 3, limited timeline and resources. So now that we have see all the 3 challenges, so how do we address all this? So we believe there's an answer for you. So we believe Infra as Code can solve all this problem. So with that, I will go through 4 benefits of Infra as Code to see how do we tackle this problem. So it's Infra as Code to the rescue. So what is exactly Infra as Code? So if you follow me through, is a method of writing and deploying machine readable file that generate service component. Quite cheap, right? So make it easy. So it's a process of managing and infrastructure through code. Okay, how exactly it works? So you think of your component, the main core component infrastructure like firewall, network, server, storage, databases. Think of them as Lego, building blocks. So we turn these building blocks into individual codes, into modules. And you use this module to apply and to construct your infrastructure. So for example, I take a building block of EC2, which is a VM in AWS. So I write this code. I input a parameter. So the parameter can be include like the subnet L1, the security group, image type, the instance type that we mentioned earlier on that we click through. We provision it to get your web compartment, and you can have different flavors of VM inside. Likewise, the same piece of code you apply with the different parameters, you can form the air compartment with different flavors. So with that individual component, we piece it together. Example, we apply a firewall code, a server code, storage code, database code, network code, and we form it and we launch the infrastructure in the cloud. So good info. So how does this help me? So let me jump straight to the benefit. So benefit number 1, automating infrastructure in a faster, repeatable and consistent manner. So how does it help? Traditionally, we want to deploy our infrastructure, so we always have this 3 environment is quite the minimum. So we have the SIT, the UAT and the production. So there may be difference in size, but we always try to ensure that we provision using the same images, like image number 1 for Windows, the Linux image number 1, so to be consistent. So let's say we do some testing and we need to change some firewall rules in the SIT. So we do in the SIT, we can say okay, we do in the UAT and do in production. So no problem. But let's say 6 months down the road or 8 months down the road, we want to deploy some new servers, some new Windows servers. So being human, we make mistakes, or being lazy, we just choose any of the images. So just how you remember, when you scroll down Windows, there are actually a lot of flavors that you can use. So you may launch a Windows image using number 2 and launch a firewall. You can say, okay, no problem. So you do in the SIT, but you are using back the same image number 1 by rule. So UAT still pass because maybe image number 1 and 2, the hardening rules are not much difference. But when it comes to production, you choose the image number 3. You apply the rules, but things don't work because 3, 1 and 2 may have a big difference. So things don't work and you do not know what goes wrong and it's very hard to trace back. So but with infrastructure as code, likewise, if you want to provision the 3 same environment, we run the code to provision the environment, and we want to make changes, that's the same thing like 6 months, 8 months down the road. We apply the firewall rule example, we do it in the SIT, UAT, production. We can ensure that by using this code, the same rules apply consistently across the 3 environment, and we want to launch new services, new Windows, we apply the code to the 3 environment. So regardless of size, we can actually ensure consistency because we are using the same image and the same firewall rules to apply across. So Infra as code will help to prevent configuration drift and will give you a consistent environment. And because everything is in the code, it's auditable, it's traceable, and it's easily to spot what the mistakes made there. So let me go to benefit number 2, enforcing policies in code. So now that we know how to provision your infra and code, so being human again, we may make mistakes. So we may provision a file server, S3 bucket example, but we did not turn on encryption. So we may deploy a server with hard disk not encrypted, or a plain database that's not encrypted. So with policy as code, actually we can implement all this encryption right at the code level, so that the moment that you spin up, you know that it's already encrypted. And all the firewall rules apply, like the no port AP, no HTTP as an extra. So we can also use the third-party tools like Cloud Custodian to actually check all the codes. So this will prevent any unauthorized access to your services, to your resources. So let me go to benefit number 3, reduce specialist contention. So if you remember, earlier on we talked about this schedule 16 weeks. So what happens is in infra as code, we start off with a plan. So the solution architect will come up with a design for the infra that you need. So at the point, the starting point of the design, so you will gather all the system engineer for the sizing of the server, the storage engineer, network engineer, and power engineer. So they will work out a plan together. And this can be done concurrently, and you don't need to be independent of each other. So it saves you a lot of time, because let's say you want to do the traditional way, your server cannot be set up until your network is done, kind of thing. So once this plan is formed by the solution architect, we will hand this over to the DevOps or let's say our engineer. So this guy will construct the plan, the infra as code plan, using Terraform example, and apply it to form the infrastructure. So this guy will say IC rocks. So number 4, protecting infrastructure in codes. So like what Spider-Man always say, great power comes with responsibility. So you must always protect your property. So you may ask me, isn't this already protecting your property? So this somehow true. So these are actually securing your resources. But somehow you need to protect it. For example, when I spin up my server, I may want to enable termination protection so that an engineer that log in cannot be accidentally coming in and click and destroy your server or your database. You enable the deletion policy, or you always enable the create a snapshot before delete so that if you accidentally do something, you can actually roll back the mistakes made. So this is where you come in to protect your infrastructure. So, talking so much about all these things, so what are the tools that are available for infrastructure as code? So actually in all the cloud provider, the main three, like AWS, Azure, and Google, they actually have their own IAC tools, Cloud Formation, Resource Manager, World Cloud Deployment Manager. But the bad thing about this part is because they have their own languages, and they only work for their own provider, so we cannot apply AWS code in Azure to spin up architecture. So that's why we are introducing this tool called Terraform as an infra as code tool. So what are the characteristic feature of Terraform? So it's a platform agnostic. So it's a sys army of the IAC tools. It works with all the cloud provider. It's security, so you just need to declare what you want and get the end state of you want, and it store this state in the TF state file, so it's aware of the delta change. So every changes you make to the infrastructure, it's actually aware of what is going on in the step. Yeah. And it's also recommended by GovTech. So how does it work? So we treat our infrastructure as a plan, like building a skyscraper. So you remember the plan that we talked about earlier on. So the plan, you have a structural engineer doing the work, you have electrical engineer doing the work. Likewise, you have all the system engineer, the power engineer that give the input, and the cloud engineer that construct this plan. And you apply this plan to start the constructions in the cloud. So this is how the infrastructure as code works in the cloud. So with that, I will hand over to Emil and Peter here to run through a demo to showcase to you how do you spin up infrastructure in cloud using the IAC.
So remember just now my colleague Kagwan mentioned that actually to provision a server in the cloud, in this case AWS, it took around 7 steps, 11 clicks, and 5 minutes. So all this 7 steps is done across different screens. So it's a bit hard to review and ensure you get the correct configuration inside. So let's take a look on how we are actually doing this in Terraform. So first, you have a common building block, which is the EC2 building block for your VM. And then we add the parameter that make this VM a web server. For example, we select the OS image that's running Apache web server and how many instances of this web server we want to launch. In this case, we want to launch 2, but it can be any number. And after that, we will assign the security group, which is like the VM level firewall. So we have been doing this approach on building this complicated compliance module, and based on our statistic, it took around 4 hours to build all this. But due to the time constraint, today we will focus on the internet zone, which is consisting of 2 tiers, app and web. And how are we going to do the demo? Actually, we have a Terraform script that is already reviewed by the team of specialists, say the network engineer, firewall engineer, solution architect. And then our operation engineer just need to apply this script using Terraform, and we will end up with this setup. So at the end of the demo, we will build the subnet, which is just the network segregation for your app and web tier, security components such as firewalls, NAT gateway for the integration with external services, and of course the VM on top of EC2. And on top of that, we will also provision the load balancer. Okay. So before we go into the demo, let me show you the AWS console to show that we actually doing this on the new environment where nothing is actually running at the moment. So from here we see there's no running servers, there's no load balancer, and we only have the default resources that come with the new AWS account, let's say the default subnet, default security group, and default network SCL, which is your firewall rules. Okay, so now I'm going to apply the Terraform script. So the first step in applying Terraform script is the planning step. This Terraform will actually read the current state of the environment and compare it against the script that we have. So from here, it will give us the summary of what needs to be provisioned. So the text that you see scrolling down very fast right now is just a list of the resources that Terraform need to provision in AWS to create our infrastructure. And from here, we can actually see the summary that it only have like 173 resources to create and nothing to change, nothing to destroy. It's because we are building this against a new environment. So this can act kind of like a checksum for the operation guy when they execute the script. So before it apply the changes, Terraform will ask for your permission whether you want to proceed or not. So in this case, we will enter yes. Okay. So once we enter yes, Terraform will start provisioning the resources. So if you can see the second screen there, that one will act as a tracker on where we are doing the infrastructure build on this demo. So now we are currently building the subnet, which is just a compartment for the app and web tier. And after that, Terraform will continue for provisioning the next resources, which is the security group and the network SCL. So network SCL is just like your standard firewall rules, and security group is your VM level firewall. So this is one of the important feature, because if you don't set this up right, AWS will deny our traffic to the VM. And if you are doing this manually, most of the people tend to forget to assign the security group to the EC2, which is the VM, and you cannot access other services there. And this might take some time to troubleshoot. Because we are doing this the IAC way, so we can prevent this wasting time unnecessarily by reviewing the code and ensure there's a proper security group assigned to your VMs. Okay. And yeah. So if we go to the console now, we should see that there is a new subnet being created. Yeah, so we have 8 new subnet being created on top of the default one, and same with the security group. So now we have the security group for the web instance. So if we dig deeper, we can see that because this is for the web instance, we can see that it is allowing traffic on the port 80. And okay. So the next resources that for the provision will be the NAT gateway for just a routing table for the integration with the external service like SyncPass, CorePass, or MyInfo. Okay, so the next one, Terraform will also provision the EC2 instances for us. EC2 instances is just a virtual machines. So this virtual machines will be the one that is running your app and web server. And the special thing about EC2, right, it supports multiple AZ setup or multiple availability zones. Basically, just like setting up your server across multiple DC for higher availability and resiliency. So in case of one of the DC in AWS went down, your application will not be infected. And yeah, so if I go to the console now, I should see this EC2 instances running. Yeah, so we have 4 running instances. And so basically we have 2 web server and 2 app server running across multiple availability zones in Amazon data center. And the next component that is currently still being provisioned is the load balancer. And because we have multiple AZ set up for our VMs, we need the load balancer to route the traffic to the server that is up and running and with the lowest utilization. And yeah, now it's completed provisioning the load balancer. So if we go back to the EC2 dashboard, then we can see there are 2 load balancers up and running. Okay, so this is our web instance load balancer. If I click this URL link, we should be able to see that our app server is up and running and ready to set the application deployment. Okay. So now I'm going to access our network balancer. Copy this. So we have our Tomcat up and running behind the web servers. And okay, another thing that I'm going to show you that actually when we provision the VM, we enable the termination policy. So this will prevent the operation guy from terminating the servers by accident, because in the cloud it's quite easy to terminate the server just by clicking a button. Okay, so let's say I'm a operation engineer, I'm doing the maintenance, and because of the route of sleep or something, then I mistakenly click terminate on this instance. This will not allow me to proceed because we enable the termination policy in the code. Even I click this, it will not terminate the server. So this will ensure there's no downtime because somebody mistakenly terminate the servers. Yeah, that's all for the demo today, and I will hand over the presentation back to my colleague Taiguan. Thank you.
Okay, just to recap a bit, just how we mentioned some of the challenges that we face and how IDC tackle all these challenges.
So, challenge number 1, compliance requirement. So with IAC, you can enforce policy in code. You can protect your infrastructure in code. Challenge number 2, which is the most common one, human errors, because these are the majority of errors that we make. So by automating the infrastructure in using code, we can actually deploy it over and over again consistently. And by enforcing all this policy and protect infrastructure in code, so that you can see that just now when Endo try to delete the infrastructure that is spin up, we can't do so because it's already protected. And the third point, limited time resources. He's one guy there doing all this job of all these people. the system engineer, because we only need them at the planning stage. So once the plan is formed, one person can execute and actually spin up the entire infrastructure. So lastly, for the closing for this session, how can the courier help? So we understand how the cloud works. We understand the government architecture policy. We have experienced cloud. Peter here, to design your infrastructure, and we automate your infrastructure like what you've seen earlier on, and we're already doing it. So in fact, we already done using infrastructure to spin up like what Ken say for one of the projects, and it's already at the UAT stage now. So we are maintaining this infrastructure, the UAT environment through Terraform. So with that, I will hand over to Mike for the next session. Over to you, Mike. Thank you.